Hi, 7th graders. Today we are going to be looking at a video about how sedimentary rock is formed, and we're going to use a model for this. Right here with me, I have my daughter, Charlotte. Say hello, Charlotte.
Hi!
So Charlotte is 7, and she's going to be my assistant today. During this video, we're going to look at two things. First of all, we have some sedimentary rock that exists. These are both examples of something called sandstone. And this one has a sort of a more grainy feel to it. This one is a little bit smoother, but you can see some of the layers that sometimes you see in sedimentary rock. And then we have over here, weirdly enough, we have some candy that I've smashed up. So these are all hard candies. You can see that there's like peppermints and butterscotch candies. We like to call this in my family old lady candy. But anyway, we have all of these pieces that have been smashed up, and those are representing sediments. Remember that sediments are small pieces of rock and stone that have broken down in some way. They can be sand. They can be really, really, really fine, like some of these pieces here that you can see on my hand. They're really, really tiny, right? They can be like a powder. Some of these are sort of powdery. You can't even see that. And some of them are bigger, so it's sort of like pebbles or rocks. Oftentimes sediments are rounded. These are not really rounded, but a lot of times they are. The ones we made, we couldn't actually make them rounded. That would have been too difficult. But we're going to work with these guys. So remember that when sedimentary rock is formed, what we end up having is sediments that are blown by wind or by water into some body of water. Usually they go downstream or something, and they're pushed downstream by fast-moving water, and they eventually end up into a calm body of water, like an ocean or a lake, where the water is not moving constantly. And as a result, the gravity allows the gravity pulls those sediments down to the bottom of the water because they are more dense than the water that they're in. And so they then fall, right? They are deposited down at the bottom of the ocean, and then they're eroded down. There's erosion that happens that brings them downstream. Then they are deposited into the water. They land on the bottom of the ocean. Then other sediments fall on top of them and squeeze them down. We call that compaction. And then they get cemented together by minerals or other chemicals in the water that sort of bind them together, kind of like a glue. So in this model we're looking at, what I've got these sediments, and I've got a mix of sediments. And what I'm going to do is I'm going to deposit them. So I'm going to use this cup over here. I'm going to put a cup down. And in this model, if I put some of these sediments into the cup, various sizes. You can see there's a variety of different sizes here. I'm going to put a bunch of these sediments into the cup. And what I'm going to do is then we need to compact it. So we can assume that these have been eroded into this place. They have been deposited. Now there's not water here, so that's a big difference from the model. And we need to compact it. So to compact it, what we're going to do is we're going to take another cup, and I'm going to put it on top of the sediments there, right? And then what I'm going to do is I'm going to put a little bit of, so to take the place of the minerals in the water, I'm going to do a little spray of water in there just to represent the idea that there's something going to go in there that's going to bind it together. In this case, it's going to be the sugar of this model, but obviously that's not true in the real world. In the real world, it's just minerals. And then what we're going to do is we're going to place a large book on top of it. And we're going to squeeze it down. So we're going to basically sit that in place, and we're going to let that go for a long period of time. Charlotte's going to push it down for us a little bit, but we're actually just going to let it sit there. You can move your hands, and it's going to sit there for 2 or 3 hours, maybe even longer. And what's going to happen next is we're going to come back, and obviously the one that I've just put in this place now won't be compacted yet. It won't be all stuck together. It'll still be pretty loose. You can see that. But even a little bit of pressure got some of it to stick together, but it's not fully stuck together. What I'm going to show you now is I'm going to show you some of these models that I made yesterday. So here's an example of one that was made out of one type of mineral, quote mineral, not actual mineral, right? It's one type of candy, so you can see it's all pretty much the same color. And you can see the pieces are sort of stuck together. They're in one piece, but they are, and you can see them that they're sort of distinct still. It's very clear that they are separate from one another. I'm going to show you another one. This one is modeling a type of sedimentary rock that's made of multiple types of minerals. Each mineral has its own color and feature, and this is an example of a mineral that's been made of multiple types of minerals. You can still see the jagged parts together, and they're sort of stuck together. but they are distinct from each other. You can see where one starts and the other one ends. Finally, I'm going to show you one where I put layered two types of sedimentary rock, one on top of the other, to show the layers. So again, we've got on the bottom, so with this model here, you can see that there's one type of sedimentary rock on the bottom layer, and then a different type that's been formed right on top of it. And so that's where we have the two different layers, or those layers that you see in sedimentary rock. So that's a little bit about how sedimentary rock is formed in this model that we made out of candy. In the real world, remember, it's a little bit different, but the same process. Remember, stuff gets pushed down a river, gets put, or by wind, it gets put into a body of water, it gets compacted and squeezed together, and then cemented together. Now, on the flip side, I want to talk to you briefly about how these rocks can then break down, and I want to use one of our models to show you this. So with our model, we can know that this is sedimentary rock because it breaks apart fairly easily. So in this model, you can see that I can break it, and it shatters back into the little pieces that were already part of it. See how quickly that breaks apart? That's a pretty good example of sedimentary rock because it breaks back into the little particles it was made of, and it makes a big mess. Now, I'm going to wash my hands briefly. Hold tight. Okay, so now I've washed my hands, and we can see our shattered and broken sedimentary rock pieces. Now we're going to look at some actual sedimentary rock. So I'm going to slide this underneath the camera, and what you've got here are the two pieces of sedimentary rock. And what I'm going to do is I'm actually going to use another piece of rock that's harder, and I'm going to rub it against this piece of sandstone we have here. And when I do that, what you're going to notice, hopefully you can see this, I'm not sure if you can see it, I'll zoom in on a second. As I scrape the other piece of rock against the sandstone, pieces of sand have broken off, or look like pieces of sand, and you can see that powder. Oh look, see, I left this and picked this up, and you can see there's all of this stuff that's come right off the rock. So it breaks apart, sort of like that piece of candy broke apart. And so that's what we look at, that's what we see when we see sedimentary rock forming.